the unknown mechanic back again, and I thought I would film this one. Ran into some difficulty. This channel is for a shop owner who doesn't have mechanics that are proficient and always needing help. It's also for the aspiring mechanic that wants to be able to proceed through a job, a difficult job, start to finish, without asking for help. And also the homeowner do-it-yourselfer who may want to tackle this job on your own and see the proper tools, techniques, and what's necessary to do a very professional, permanent, long-lasting repair. So I've already done a lot of work to this saw. It had a lot of worn-out parts. The oiler drive gear, the clutch drum, the clutch bearing, the intake adapter was broken, hardware, miscellaneous hardware around the saw, just a lot of work. And I ran into, oh, by the way, this saw belongs to Yancey Lugosi, and it just says call with estimate, and starts and floods won't stay running. And I've already addressed all those issues, called them, got an approval. So what I ran into is to the very end of the repair, and the inside spike is held on by wire. He's wired the lower spike mounting screw in place of that screw. And so, I was hoping that I would just be able to cut the wire and, put in the proper screw. This is a special screw. It's got a captive washer, dry adhesive on it, and it is 1 grade harder than a standard screw. It's a 10.8, and these other ones are, I can't read it, but it's less than that. But what I found was there's no threads in the crankcase here, and that hole is pretty stripped. So initially I thought I would use my Heli-coil. I've got a 5mm by 0.8 Heli-coil kit. I use this quite often, and I like Heli-coils a lot. If they're installed properly, they're very strong. If they're installed improperly, they'll pull out, and we're going to show an example of that. So the pilot drill that's supposed to be for a 5mm Heli-coil is a 13/64. So when I take my 13/64 Heli-coil pilot drill and I put it in the hole here, that hole is already larger than this drill. And if I were to attempt a Heli-coil in a hole that large, it would pull out, it would fail. And so on rare occasion, you have to graduate to the next type of thread repair insert. And I'm not talking about a Timesert. A Timesert is very, very similar to a Heli-coil, except that the threads are synchronized, peak to valley, whereas a Heli-coil insert, the threads are synchronized point to point. And Timeserts and Heli-coils share a 5mm STI tap, and STI stands for Standard Thread Insert. So the drill and the tap for a Timesert are identical to the drill and the tap for a Heli-coil. So if I try to put a a Timesert in this, it's not going to be much better than a Heli-coil. What I have to do is I have to go to a thicker walled insert, and so they are called Keenserts with a K, and I've got different vendors for these. This one is Recoil, and they call it a Keysert, but it's exactly the same thing. It's a solid insert, and the wall thickness is greater than a Timesert or a Heli-coil, and that means that the pilot drill will be big enough that it'll clean this hole up. The outside threads of a 5mm by 0.8 Keensert are 8 by 1.25. So it's 8mm on the OD, 5mm on the ID. And this is what's considered a thin wall insert. Keenserts come in a thick wall and a thin wall. And I don't need to go to a thick wall insert. A thin wall Keensert will work in this application. Now, I'm going to have to use this. These are not available in different lengths. They pretty much come in a standard 1.5. The diameter would equal the length of a standard Keensert. So this is 7.5mm long. And I'm going to be using a standard 8mm by 1.25 tap. There is no, this is not a special tap. This is a standard tap. Don't need any special drills or taps to do this. And but what I am going to do is to avoid drilling. You have to drill exactly perpendicular to the crankcase face, and a lot of novice mechanics will try to do that by hand, and there's really no degree of accuracy, no matter how steady you are, to get exactly perpendicular to the crankcase. So rather than mount this up on the drill press, I could do that. I could remove the starter and then block up this side of the crankcase, and then it would be on the drill press table, and it would be very precise. But that's a lot of setup time, and I found a faster way to do that I like. These are made by Big Gator Tools, and they are drill and tap guides, and they make quite a variety of sizes. So I picked out the ones that I want to use, and by clamping this drill guide onto the bar pad, that is going to guarantee that I am going to be drilling very, very square to the crankcase, and there's no possibility for error using these tools. And so I would recommend these, for guys that want to do a high quality, long-lasting, permanent repair. Now, in order to mount this onto the bar pad, I'm going to be removing one of the bar studs, and I am going to be using the threaded hole in the crankcase to fix a clamping bolt, and I've got some drill press clamping hardware kit, and I'm going to clamp that drill guide onto the bar pad. And what I'm trying to avoid doing is, I'm going to get my whiteboard here. Your theoretical thread percentage for an 8mm by 1.25, you would be using a 17/64 drill bit, which is going to give you a 265 thousandths diameter hole. And when you drill that hole, you will end up with an 81% percentage of thread. And that's pretty good in a soft material like this magnesium alloy. If this was some type of steel parent material or cast iron, a very hard material, this would be a lower percentage. The hole would be bigger and the thread percentage would be around 60%. But this is what you're shooting for in a soft material. Now, if you were to resort to using a helicoil in a hole that was already larger than 265, what you would end up with, you would end up with something like that. And your helicoil, it would pull out. You just don't, if the hole is too big, you've got to graduate above a helicoil or a Timesert. So this is what, I'm trying to teach you guys today. Probably don't want to see my whiteboard again. So I'm going to remove this bar plate and one of the bar studs. And I've got my trusty bar stud puller. It's a collet type. I use this in one of my other videos, a Stihl professional chainsaw bar stud repair. And so I'm using it again. This is not my first video on a spike mounting thread problem. I was doing, let's see, I think it was a 661, an MS 661. It had a missing spike and one of the screws was broken off, and it was not broken off flush, it was recessed down in the hole. And so if you want to see that video, that's interesting as well. This is a similar problem, just a little different. I'm going to be using the Timesert today. Tighten this down. And it's pretty important to have a bumper spike mounted on a pro saw. And if you don't have a spike mounted, it's harder to control the saw when it's in the wood and you're trying to make accurate cuts. So this is going to give me a threaded hole in a very flat surface. I'm going to take advantage of it. So the first one I want to use is the drill guide. Use one of the bar nuts. This is going to work well because the bar nut's very wide. All right, this is my favorite drill. I like this drill because it's got a very, very narrow profile. You can really get into tight areas. And it's got a lot of power. It's reversible. It's a snap-on, PDA 3000, I believe. Give it a little oil before it gets started. Okay, and one of the secrets to producing a hole that is precisely the size or as close as possible to the drill bit size is the right cutting fluid. And also this drill, this is a coated drill. This is a black oxide, and aluminum and aluminum alloys do not like to stick to a black oxide coated drill. If this was a bright finish drill, the cutting fluid would be even more critical. So this is what I like to use. Use this for decades. This is the good stuff. This is Winbro Alume Tap, Winfield Brooks, and this is still available. You can get this. This is excellent cutting fluid, and it will produce, you've got a very sharp drill that's coated using the best cutting fluid, and it is going to produce a hole that is 0.265. Make sure my drill's in forward. And I'm all the way through. That was pretty successful. Now I'm going to change the drill guide to a tap guide. I'm going to bring you in for a close-up and you can look at this under the light. Let's see. Okay, very, very smooth surface finish, hole diameter 0.265, exactly perpendicular to the bar pad. I'm going to use the tap guide. There. Okay, it's the same thing. This tap is being held, guided by this Big Gator tool tap guide, and it's exactly perpendicular to the bar pad in the crankcase. Same thing, I'm going to be using, if you use the best cutting fluid, you will produce a perfect finish, thread finish. Just pause once in a while, add some more. On this type of alloy, it is not necessary to back the tap up and break the chips off. That's for very hard materials. I'm sure that that is deep enough. If I had a longer Timesert, I would go all the way through and take advantage of the deeper hole. But Timeserts are very difficult to get in anything but the standard length. Now that the drilling and tapping operation are done, I no longer need the clamping, the bolt, the nut, the clamp. Don't need it. I'm going to remove it. We're done with that part. And bring it back in again. Okay, I'll get that off. I'll bring it back in one more time. It's better, easier to see. Okay, you see excellent thread finish. Hole tolerance, perfect. Now, these Timeserts they have installation tangs, and I do have the right tool. The tool has some grooves that will accept those tangs. And this can be mounted into a small tap wrench. Okay, I think that will work. And let's see, I like to use some Loctite on the outer diameter. They can be started by hand. and you basically go down flush. Okay, so it's now flush with the crankcase, and what I'm going to do now is I'm going to turn the tool upside down, and that it's made to drive the locking tangs. And once the locking tangs are driven into the parent material, then it's permanently locked. Could go a little deeper. And now the tangs are driven in, and that insert is permanently in there. And that is how you repair an oversized hole that's too large to accept a Heli-coil or a Timesert. So now my stock 5mm screw, along with the new bumper spike. Where is the spike? Here it is. So I can mount this spike and the chain catcher and tighten that down, and it will hold. That's a very, very permanent repair, long life, permanent repair. So if a Heli-coil won't work, do your homework and get yourself, this is a recoil keysert. They're also going under the name of Keensert with a K. So I hope this helps. This is the way a professional would repair this. If you like the video, hit the thumbs up and the subscribe. Watch all my other videos, and feel free to leave some comments. Nobody ever leaves any comments, so I don't know if I'm doing a good job. So, but what you don't want to do is do something like this. You're not going to get 81%. You're going to end up with 10%, 20, 30% thread, and that's just not going to work. The insert will pull out of the parent material. And if you install Heli-coils correctly and you install Keenserts correctly, they are stronger than the original threads in the aluminum alloy parent material. So I'm going to save you from the nuts and bolts putting it all back together, but I guarantee you this will bolt up here, and I can tighten that down super tight, and it'll stay there. So what you don't want to do is try to use wire and wire the stuff together. That's a no-no. And don't use a Heli-coil in an extra large hole. So that's it for today for the Unknown Mechanic.